So we finished up talking about just arithmetic sequences in the last video, and today we're going to pick up with arithmetic series and try to find the sum of finite arithmetic series. So there's a story about this mathematician named Gauss, and his elementary teacher got frustrated with him because he was one of those kids that was, just always talking or always up and moving around and never doing what he was supposed to do. So she thought, well, I've got something that'll keep him busy for a while so I can go take care of my other kids. And she told him, why don't you go add up all of the integers from 1 to 100? And he did it in just a few seconds. How do you think he did it? Take a second, pause the video, see if you can figure it out. So what he did was he thought about if you arranged all the numbers from 1 to 50 and then paired those up with the numbers from 100 to 51, 1 to 50 in increasing order, 100 to 51 in decreasing order. If you start pairing those up, you realize that every one of those pairs will add up to 101. So if you took the first number and the last number in that sequence, added them together, you get 101, and that'll be the same sum the whole way through, no matter which pair you looked at. And he knew that there would be 50 pairs of them because there were 100 terms. So he just did 101 times 50, and he got 50/50. So this leads us to a way that we can actually find the sum of a finite arithmetic sequence in a formula form. And that is, we look at how many terms there are, we cut that in half, that's the 50, and then we multiply that by the sum of the first term and the last term, the first term and the last term. And that's going to give us the sum of all of those terms in that sequence. So let's just do a few of the ones that we see below here. So if I wanted to find the sum of the first 50 integers, I have to think about my sum, S sub n, being n over 2 times a sub 1 plus a sub n. So we know that n is 50. Okay, so I'm going to put 50 everywhere I see n. And that's going to make this the sum of the first 50 terms equals 50 divided by 2 times a sub 1 plus a sub 50. Well, we have to think about what our first term and our last term would be in that sequence, and the first term would just be 1. When we're talking about the first 50 integers, we start with 1, and our last term would be 50. So I can put all of that into my formula, and I'm going to get the sum of the first 50 integers is 50 divided by 2 times 1 plus 50, which is 25 times 51. And then it's just a matter of typing that into our calculator to get 1275. Okay, so the formula itself is pretty easy to use. Go ahead and pause the video here and try part D, and then come back when you're done. Okay, check it out. How'd you do? So remember, our formula has us taking however many terms there are, which if it's the first 200 integers, there will be 200 terms where the first term is 1 and the last term is 200. Plug that in to our formula for n. N is 200. And then figure out what your first term and your 200th term are, and then write your equation. So it'll be 200 divided by 2 is 100 times 1 plus 200. So 100 times 201 is 20,100. There's a couple of problems on the front here if you want to try those. Pause the video, come back, and I'll have the answers for you, but I'm not going to go through the same process we just did, especially since part C is one that we've already talked about. Just a couple of quick notes as you're coming back to check your answers. First of all, part C we did in the example above with Gauss, but part A, notice that these are odd integers, and we talked in a previous lesson or in one of the assignments about how to write the equation for odd integers, and this is it. But that's not really relevant for us at the moment, but I mean, it's nice to see that will generate your odd numbers. And then you have your formula, you get 100. Here, the only thing we really do is we replace n with w, and we get the same exact formula, just with w instead of n. Okay, so just some quick terminology. When we talk about the sum of the first n terms of an infinite sequence, it's called the nth partial sum. So we're looking at, you have an infinite sequence, find the sum of the first 10 terms of that, or the first 100 terms of that, or the first 10,000 terms of that. That's the nth partial sum. So if I want to find the 150th partial sum of this arithmetic sequence, well, we got to know a little bit of information here. So first thing we have to figure out is, what is this pattern? What's happening to get to each term because we are going to have to write an equation for this pattern. So the first thing I've got to be able to do is come up with an equation for a sub n. Now, I do know it's arithmetic, so that tells me I can use what we talked about in the previous video, where I can take a sub 1 and I can add d times n minus 1 to that. So to get the nth term here, a sub 1 is 5. What I'm doing to get to each term, it looks like I'm adding 11 each time. So that's d. So my equation would become 5 plus 11 times n minus 1, and you can leave it like that. Some of you may prefer to do the 0th term, and you may have come up with a sub n equals negative 6 plus 11d. That is also okay. Either one of those would work. But the whole point of getting that is because when I use my formula, I have to know what the first term is and what the last term in my sequence is. So I now need to know what the 150th term of the sequence is. Well, that's why we generate these equations, because it allows us to find that 150th term. So using either equation, I'll use the one I wrote first, I would have 150 for n, and then I just have to simplify that. And that's when using your calculator is nice, and we get 1644. Now I've got everything I need to actually find the sum of the first 150 terms. So that's what I'm going to do using our formula from the previous slide. We now know everything in that formula. I know what n is going to be. N is going to be 150, so 150, 150. This is the 150th term, which we just found is 1644. So the sum of the first 150 terms will be 150 divided by 2 times a sub 1, which is 5, plus a sub n, well, that's 150 in our case, so a sub 150 is 1644. Well, now I've got everything I need. I just need to type that into my calculator. And when you do so, you should get 123,675. Now that's going to be a whole lot quicker to use that approach than it would be if we actually just generated all of those terms and added them together. Okay, so I'm going to have you work through this one in steps. The first thing I want you to do is pause the video and see if you can come up with a way to write the nth term of this sequence. In other words, what's the formula for this sequence? So pause the video, come back and check it when you're done. Okay, so that's the first step of the process. You may have written this if you use the first term to write your equation, or you may have written this if you use the 0 term. Okay, next step. Go ahead and generate the 16th term. So write down your first term, a sub 1, and then figure out what your 16th term is. Again, pause the video, come back and check your answer. All right, once again, hopefully you're able to find those terms pretty easily. We're on 100th term, or our first term is 100. The 16th term is 25. Now the next step is to actually go through and generate the sum. So pause the video again, see if you can find the 16th partial sum. So the sum of the first 16 terms using our formula. All right, so we know that n is going to be 16 in our formula. So everywhere I saw n, I replaced with 16, knowing that this meant the 16th term, which is 25, and then just evaluate. Okay, if you want to try example 6, pause the video, try it, read through it, see if you can make sense of what it's saying, and then when you're done, come back and I'll have the work up for you, but it's something that you can look at as kind of an extension. I'm not really concerned that you are doing that type of problem right now. So if you want to try it, pause the video, come back and check your answer. Okay, hopefully you were able to kind of work through this. Again, if you did it, great. If not, that's okay as well. I've got this set up in phases. The first thing that's important to understand is that we're actually finding the 10th partial sum because this is year 1, and then we increase for 9 years following that. So we're really looking for year 10. Find your generator for a sub n, work through that using my first year plus how much I'm increasing for each year. Then I use that to find my 10th term because I need that to find the 10th partial sum. And then I use my formula to find my sum. So that's the sum of the first 10 years that he would be in business. Okay, so there's going to be an assignment for this on Google Classroom. Go ahead and try it and see how you do.